we have to focus on this is a circle, correct? And what is the given? Angle ACB. Suppose this is the angle ACB. This is a 65 degree, correct? Means it is a supposed to be center of the circle. So find out the arc AB first. How to find out the arc AB? It is angle ACB is inscribed angle, and we know that inscribed angle theorem, that is angle ACB is equal to half into measure of arc AB, correct? Means that measure of arc AB is equal to 130 degree because angle ACB is equal to 65 degree. Then we have to find out what measure of arc ACB. Measure of arc ACB. That is, we know that the measure of arc AB we have to find out just. And we know that the measure of a whole circle is 360 degree. So 360 degree minus 130 degree, that will get the 230 degree, correct? Means here we have to get easily option D. D is the correct option, correct? Then focus here, what is the given? Segment AB is parallel to y-axis and the coordinate of point A 1, 3. Then the coordinate of point B can be. So just focus on the concept of if AB is parallel to y-axis, that indicates that their equation. What is that equation? If line is parallel to y-axis, then the equation of that line is equal to x is equal to constant. Here this line is passes through the point 1, 3, that is the A point. And if x is the constant, that indicates that one x coordinate is fixed. And we have to focus on that option. Here we'll get the option only 1 minus 3. 1 is fixed. So again, D option is correct. Then focus on the fourth MCQ. What is the fourth MCQ? Find the side of a cube of a volume 1 meter cube. So we know that what is the cube? Volume of a cube, that is L cube. So here we have to write L cube is equal to 1. Taking cube root both sides. So L is equal to 1 meter. But here when we focus on an option, meter is not given. All are in units centimeter. So 1 meter is equal to 100 centimeter. That is C option is correct. Then focus on if sine theta is equal to 11 upon 61. What is here? If sine theta is equal to 11 upon 61, then find the value of cos theta. So we have to use the identities. What is the identities? Cos square theta is equal to 1 minus sine square theta. Cos square theta is equal to 1 minus sine square theta. So here we have to focus on, we have to put the value of sine square theta here. So 1 minus sine square theta, that is 1 minus 11 upon 61 bracket square, correct? What we write here? 1 minus 11 upon 61 bracket square. So cos square theta, see here, we have to focus on cos square theta is equal to 1 minus 121 upon 3721. It is the square of 11 and 61. Here denominator are not same, so we have to try to same the denominator. So what will we get? 3721 minus 120. See here, 3721 minus 120 upon 3721. So what will we get? We get 3600 upon 3721, correct? Then taking square root both sides. So cos theta, what is the value of cos theta? See here, 60 upon 61. Then focus here, next question. That is find k if r 1 minus 1, s minus 2k and slope of a line rs is minus 2. So here what is the given? R and S coordinate is given. So we have to take, let R is supposed to be x1, y1, that is 1 minus 1. S, that is x2, y2, that is minus 2k. And slope of line RS is given, that is minus 2. Find the value of k. So slope of a line formula. What is the slope of the line? Here, slope of the line is nothing but, see, focus here that formula, y2 minus y1 upon x2 minus x1, correct? Slope of a line, RS, is equal to y2 minus y1 upon x2 minus x1. So put the given value. So what is the given value? See here, minus 2, that is the slope of the line. This is the given. Put y2, that is k, minus, what is the value of y1? That is minus 1. Upon x2, that is minus 2, minus x1. What is the x1? That is 1. We have to put that all value. That is minus 2 is equal to k minus, in bracket, minus 1 upon minus 2 minus 1. So therefore, what will we get? See here, that is, we'll get the value of minus 2 is equal to k. Minus minus become plus. So k plus 1 upon minus 3. Correct? So here we have to get the value of minus 2 is equal to k plus 1 upon minus 3. That minus 3 is divided, when we change the side, it is multiplied. So minus 2 into minus 3 is equal to k plus 1. That will get minus 2 into minus 3, minus minus, multiplication will be plus. That is 6 is equal to k plus 1. That is plus 1 shift here. That is minus 1. So 6 minus 1 is equal to k. So what is the value of k? It is 5. Correct? We have to focus on then third question. What is the third question? See here, two circles of radii 5.5 centimeter and 4.2 centimeter touch each other externally. Find the distance between their center. Here, two circles are externally touching circles. So we know that the touching circle theorem. If this circle R touches each other externally, the distance between their center is equal to the sum of their radii. Correct? So we have to use that touching circle theorem. That is, distance between their centers is equal to R1 plus R2. Where R1 is given, that is 5.5 centimeter. R2 is given, that is 4.2 centimeter. So here distance between their center is equal to 5.5 centimeter plus 4.2 centimeter. That will get the 9.7 centimeter. This is the correct answer. Then focus here. Fourth question. So what is the fourth question? Focus here. L. If in triangle LMN, L is equal to 5, M is equal to 13, N is equal to 12, state whether triangle LMN is a right angle triangle or not. So here we have to focus on highest value. That is, M is equal to 13. So we have to square it. M square is equal to 13 square is equal to 169. L square plus N square, that is pi square plus 12 square. Pi square, that is 25. 12 square, that is 144. It becomes 169. When we focus on both the equation, see here, this is also 169, this is also 169, correct? We have to focus on equation 1 and equation 2. That both value are same. That indicate that M square is equal to L square plus N square. That is, the biconverse of Pythagoras theorem, triangle LMN is a right angle triangle. Okay, so it is one right angle triangle. Here our first question completed. Then we have to focus on the activity question, that is question 2A. Total 3 question is given and we have to try to any 2 activity, correct? So focus on 2A first. So here we know that in question 2A, total 4 boxes given and that each box having half marks. So we have to discuss with the first question. The radii of a two circle end, the radii of a two circular end of a first term shape bucket are 14 centimeter and 7 centimeter. Height of the bucket is 30 centimeter. Complete the following activity to find the capacity of bucket in the liters. So we have to find out the capacity of a bucket. That means we have to find out the volume of a bucket. So volume of a bucket is the first term. So that is we have to write here formula for first term of a volume of a first term. That is already given. 1/3 pi r1 square plus r2 square plus r1 r2 bracket close to h, correct? So put the all given value. R1 is 14 centimeter, R2 7 centimeter, H 30 centimeter. Put the value of all here separately. So 1/3 into 22 upon 7. Here R1 square means 14 square, R2 square that is 7 square, R1 into R2 that is 14 into 7. We have to separately solve it and it become 343. What will we get here? 343. So see here we have to put in that box and draw a box again. So 1/3 into 22 upon 7 in box 343 into 30. So here that 3, see focus here, this is a 3 and here 30. So 3 ones are 3, 3 tens are 30. So 22 upon 7 into 343 and here we'll get only 10. Then 7, we have to divide it 7 and 343 and remaining value we have to multiply with, we'll get the answer 10,780 cubic centimeter. But we know that 1 cubic centimeter is nothing but 1000 cubic centimeter is nothing but 1 liter. So we have to just write here that cubic centimeter is converted into liters, that is 10.78 liters. So we have to focus on second activity. In the figure, in triangle ABC, point D on a side BC is such that angle BAC is equal to angle ADC. Complete the following activity to prove that CA square is equal to CB into CD. What will we write here? CA square is equal to CB into CD. So start with the activity. What is the activity? Focus here. See here. What is the activity? In triangle BAC. Which one triangle? C here. In triangle BAC, that is 1. Then in triangle ADC, that is 1. Correct? So in both the triangle, when we focus here, what is the given? Angle BAC congruent angle ADC, that is given. Same where angle ACB is equal to angle DCA, that is C is a common angle between these two triangles, that is the common angle. Therefore, triangle BAC similar triangle ADC, that is AA test, correct? If these two triangles are similar, their sides are in proportion. So we have to select the side, that is AC is written as the way CA upon DC is equal to CB upon CA. So CA into CA cross multiply it, that is CA square, CB into CD. Correct? So we have to complete the second activity. Then focus on a third activity. This is a trigonometry question through that section. So complete the following activity to prove 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta is equal to 2 sec square theta. So focus on activity LHS part. So 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta. Here when we observe here, that is here denominator are not same. So we have to try to same the denominator. So 1 into 1 plus sine theta, here we write 1 plus sine theta, and 1 minus sine theta into 1, here we write 1 minus sine theta. Upon these two denominator, multiply it. That is 1 minus sine theta upon 1 plus sine theta in both the bracket. So here 1 plus sine theta plus 1 minus sine theta. Here plus sine theta minus sine theta get cancelled. And here a minus b, a plus b, it is a form of a square minus b square. That will write here 1 minus sine square theta. Means we have to use the formula for a square minus b square. Then here if sine theta get cancelled in numerator. So 1 plus 1 remaining 2. And we know that again identities, that 1 minus sine square theta is nothing but cos square theta. So 2 upon cos square theta, correct? So focus here, 2 cos square theta. Then we have to write the way 2 in bracket 1 upon cos square theta. So 1 upon cos square theta is nothing but sec square theta. So here we'll get LHS is equal to RHS. That is, what is the LHS? 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta is equal to 2 sec square theta, correct? Then 2b, that will total 5 questions is given, and we have to find out, or we have to try to at least 4 questions, that is each 2 marks. Then we have to discuss with question 2b1, that is here quadrilateral ABCD is a trapezium, side AB is parallel to side PQ is parallel to side DC. AP is equal to 15, PD is equal to 12, and QC is equal to 14 to find the value of BQ. Here what is the given? 3 sides are parallel to each other. That is side AB is parallel to side PQ is parallel to side DC. That is AB upon PD is equal to BQ upon QC. Means we have to use the theorem of 3 parallel lines and their transversal. That is already it is a application of BPT. Put the given value. So see here we have to put the value. So that is AP replaced by 15, PD replaced by 12, BQ is unknown, and QC is replaced by 14. So cross multiply it. So here 14, 15 into 14 upon 12, we have to easily find out the BQ. So cancelize it. So that will get 5 into 7 upon 2. So 35 upon 2 is BQ. 17.5. So what is the value of BQ? That is 17.5 units. Then focus on question number 2. So what is the question 2? We have to discuss. In the figure, focus here figure. Segment PS is a tangent segment. Line PR is a secant. If PQ is equal to 3.6, QR is equal to 6.4. Find the value of PS. Here, PS is a tangent and PR is a secant. So, we have to use tangent secant segment theorem. That is, PS square is equal to PQ square. See here, what we'll see here? PS square, focus on that formula. PS square is equal to PQ into PR. But here PR value is not given. So PR is nothing but CR PQ plus PR, correct? So we have to put the value of here. So PS square is equal to PQ is replaced by the value 3.6 and PR is nothing but PQ plus PR. PQ plus QR, correct? So put all the value 3.6 into 3.6 plus 6.4, correct? So it become 3.6 plus 6.4, it become 10. That will get here PS square is equal to 36. Here PS square is equal to 36. So taking square root both the sides. So PS is equal to 6 units. So what is the value of PS? 6 units. Then focus here, question number 3. That is a very easy question for a construction. Construct a tangent to a circle with center P and radius 3.2 centimeter at any point M on it. So just focus here how to draw. First take a radius 3.2 centimeter, draw a circle having center P. Then take M point on a circle and we have to draw a line segment PM, or here we have to draw a line. Then take M is as a center and we have to draw 2R. And we have to try to find out the perpendicular bisector which is passing through M point. This perpendicular bisector is nothing but tangent. So that will get the tangent L, and this is the simple question, will get the easily marks 2. Then focus on a fourth question. Find the ratio in which point T minus 1/6 divides the line segment joining the points P minus 310 and Q 6 minus 8. That indicate that we have to find out the ratio, correct? Means what is the given? P, that is x1 y1, that is minus 310. Q, that is x2 y2, that is 6 minus 8. T, that is which is dividing point of a line segment PQ, that will consider here xy, that is minus 1 6, correct? That indicates that point T divides the line segment. T divides the line segment joining the points P minus 310 and Q 6 minus 8. So we have to use the section formula. What is the section formula? That is x is equal to mx2 plus nx1 upon m plus n. Correct? So here we write x is replaced by the value minus 1. M, that is remaining same because it is unknown. X2, that is 6. N remaining same as it is. X1 replaced by the value minus 3 upon M plus N. So this M plus N is divided here. When we change the side, it is multiply. So minus 1 multiplied by M plus N, it become minus M minus N. 6 into M, that is 6M, and minus 3 into N, that is minus 3N. So see here, it become minus M minus N is equal to 6M minus 3M. We have to equate MM term one side and NN term one side. That will get 3N. That minus 3N shift here plus 3N minus N. And that minus M shift other side, that is 6M plus M. So 3N minus N, it become 2N. 6M plus M, that is 7M. So here we have to find out the ratio M upon N, it becomes 2 as to 7. So what is the ratio of M as to N? That is 2 upon 7. Then focus on next question. That is question number 5. What is here question number 5? The area of a minor sector of a circle is 3.85 centimeter square. And the measure of a central angle is 36 degree. Find the radius of the circle. So here area of a sector is equal to theta upon 360 degree into pi r square. Put the all given value. Area of a sector, that value is 3.85. See here 3.85. Theta is replaced by 36 degrees. So 36 degree upon 360 degree into pi is replaced by 22 upon 7 into r square. So we have to try to find out r square. So all constant value shift other side, that will get 3.85 into 10 into 7 upon 22. So cancelize it properly, we'll get r square is equal to 49 upon 4. Taking square root both sides. That is r is equal to 7 upon 2. That is r is nothing but 3.5 centimeter. So here what is the radius of the circle? 3.5 centimeter. Here our question 2 will be completed. Then focus on question 3. Again, question 3 is an activity type question. Each box having half marks, total 6 marks is given. So complete the following activity. We have to discuss first activity. That is, in the figure, P is the center of the circle. Measure of arc CST is 105 degree. Chord AB, congruent chord CD. Complete the following activity to find measure of arc AYC and measure of arc BD. So here we have to focus on the activity. Measure of arc AYC is equal to angle CPA. That is the given, because by definition of measure of minor arc. So measure of arc AYC, that value is given 100 degree. So because angle CPA measure is given 100 degree. So what is the measure of arc AYC? It is 100 degree, correct? Then chord AB, congruent chord CD, it is the given. Chord AB, congruent chord CD, it is the given. Therefore, we know the respective theorem. If chords are a congruent, their corresponding arc also congruent. So we have to write arc AB, congruent arc CD, that is corresponding arcs of a congruent chords. Therefore, measure of arc AB is equal to measure of arc CXD or CD, that is 105 degree. That is also given. Now we know that if it is a circle, that all arcs when we add it will get the measure of a circle, that is 360 degree, correct? So here we have to write measure of arc BD plus measure of arc AB plus measure of arc AYC plus measure of arc CXT is equal to 360 degree. That is measure of a circle. Put here proper value. Measure of arc BD is unknown. Measure of arc AB 105 degree. Measure of arc AYC we have to find here 100 degree. So put here 100. And measure of arc CXT, that is we'll find out here 105 degree. Put here is equal to 360 degree. So add it properly, that is 105 plus 100 degree plus 105, it will get 310 degree. So measure of RBD is equal to 360 degree minus 310, that will get the 50 degree, correct? So we have to complete the first activity. Then focus on a second activity, that is in right angle triangle ABE by Pythagoras theorem. We have to focus here. Which triangle is given? ABE. That is AE square is equal to AB square plus B square. In right angle triangle DBC. Focus on DBC right angle triangle. DC is a hypotenuse. So we have to write here CD square is equal to DB square plus BC square. In right angle triangle DBE. So DE square is equal to BD square plus BE square. Correct? And in right angle triangle ABC, that is we have to write by Pythagoras theorem, AC square is equal to AB square plus BC square. So adding equation 1 and 2, that is AE square plus CD square. What will we get? AB square plus B square plus BD square plus BC square. What will we get here? So see here, AB square plus B square plus BD square plus BC square. We have to arrange it. That is AB square plus BC square in first bracket and BD square plus BE square in first bracket. When we focus here, AB square plus BC square is nothing but AC square. And BD square plus B square. BD square plus BD square, that is the value of DE square. See here. So we have to put that value. So what will we get? AE square plus CD square is equal to AC square plus DE square. Here's the proof. So focus here. Third B question. This is again one construction 3B1. So what is the 3B1? Draw a circle of a radius 3.3 centimeter. Draw a chord PQ of a length 6.6 centimeter. Draw a tangent to the circle at point P and Q. Write your observation about the tangent. Here, first we have to draw a 3.3 centimeter radius having center O. Here, when we observe here 6.6, it is the diameter of the circle. So, draw the PQ here. See here, we have to draw the PQ, that is a 6.6 diameter. And we have to draw two tangent. That is, one is passing through point P and one is passing point Q. Correct? So, here, we have to extend the PQ diameter and try to draw a perpendicular which is passing through point P and passing through point Q. So here we'll get this is the perpendicular bisector. Correct? Means when we draw here two perpendicular bisector, that is this is the tangent M and this is the tangent N. And when we observe here, it is the parallel. So tangent M is parallel to tangent N. So here we complete the B1. Then focus here, question number 2. What is the question number 2? A, that is H minus 6, B, 2, 3, and C, minus 6K are the coordinate of a vertices of a triangle whose centroid is G, 1, 5. Find the H and K. So we know first the centroid formula. What is the centroid formula? X is equal to x1 plus x2 plus x3 upon 3 and y is equal to y1 plus y2 plus y3 upon 3. Correct? But we have to select first. A is considered as x1 y1, that is h minus 6. B is considered as x2 y2, that is 2 3. C is considered as x3 y3, that is minus 6k. G, that is xy, that is 1 5. So we have to easily find out the value of h and k. So x, we have to write the formula. X is equal to x1 plus x2 plus x3 upon 3. That is, put the all given value. X is replaced by 1. CR. X1 is replaced by H. X2 is replaced by 2. X3 is replaced by minus 6 upon 3. So here we'll get 3 ones are 3. That is the this denominator, shift the other side. So 3 ones are 3. H plus minus 4, because 2 minus 6 it become minus 4. And that minus 4 shift other side. So 3 plus 4 is equal to H. So what is the value of H? That is 7. Correct? Then here focus on the y coordinate. We have to write the formula. Y is equal to y1 plus y2 plus y3 upon 3. So put the all given value. Y replaced by the 5. Y1 replaced by minus 6 plus 3 plus k. That is y2 value is 3 and y3 value is k. So 5 is equal to minus 6 plus 3 plus k upon 3. Again, this 3 is here. Divide. When we change the side, it is multiply. So 5 3s are 15. Minus 6 plus 3, it become minus 3 plus k. That minus 3 shift on the other side, that is 15 plus 3, it become 18. So what is the value of k? That is 18. So h becomes 7 and k become 18. That is, we have to easily find out the value of h and k. Correct? Then focus on third question. Third, it is one theorem. So which theorem? That is the areas of similar triangle theorem. So focus on their statement. When two triangles are similar, the ratio of areas of those triangle is equal to the ratio of square of their corresponding side. That is here areas of two similar triangle theorem we have to discuss. So we have to draw two similar triangle, that is triangle ABC, similar triangle PQR. Here AD is perpendicular to BC, PS is perpendicular to QR. That is the given. What to be proved? We have to prove that triangle ABC upon triangle PQR is equal to AB square upon PQ square. is equal to BC square upon QR square is equal to AC square upon PR square. So start with the proof. Here we know that the first concept of the ratio of areas of a two triangle is equal to the ratio of product of their corresponding base and their corresponding heights. That is, we have to write here area of a triangle ABC upon area of a triangle PQR is nothing but BC upon AD. BC is the base of a first triangle and AD is the height of the first triangle. That is BC into AD. QR is the base of a second triangle and height is a PS. So we have to separate it. That is, we have to write the way BC upon QR into AD upon PS. Write here equation number 1. Then we have to select the two triangles, that is in triangle ABD and another triangle PQS. That is angle B is equal to angle Q. That is the given. Angle ADB congruent angle PSQ. That is each angle 90 degree. According to AA test, that is this both the angles are congruent, that is these two triangles are similar by AA test. So AD upon PS is equal to AB upon PQ, correct? That is the corresponding sides of similar triangle. But again, in a given part, triangle ABC similar triangle PQR, that is AB upon PQ is nothing but BC upon QR. That is the corresponding sides of similar triangle, correct? Therefore, focus on that equation 1, that equation 2 and that equation 3. That is, we have to replace BC upon QR as it is, but here AD upon PS is replaced by AB upon PQ and AB upon PQ is replaced by BC upon QR. That will get here BC upon QR into BC upon QR. So it will become BC square upon QR square. Similarly, we have to prove that area of a triangle ABC upon area of a triangle PQR is equal to AB square upon PQ square is equal to AC square upon PR square. Hence the proof. We have to discuss the areas of similar triangle theorem. Then focus on the fourth question. That is here. That is the diagram is a given and we have to find out the area of a segment. So focus on the question. In the figure, O is the center of a circle. Measure of arc PQR is equal to 60 degree. OP is equal to 10 centimeter. Find the area of shaded region. Here pi value is given 3.14. Root 3 is equal to 1.73. So first we have to write the given and to find in that according to question. Then focus on a solution. Angle PQR, that is the central angle is a given, that is measure of arc PQR. So what is the measure of arc PQR? That is a 60 degree. So what is the central angle measure? That is angle PQR also 60 degree, that is theta is 60 degree. What is the area of a shaded region? That is r square is equal to pi theta upon 360 degree minus sin theta upon 2. This is our formula. What is the formula? Area of a shaded region is equal to r square in bracket pi theta upon 360 degree minus sin theta upon 2. Put the all given value. R square is replaced by 10 square. Pi is 3.14. Theta is 60 degree upon 360 degree. Minus theta is replaced by 60 degree, that is sin 60 degree upon 2. So here 10 square, that is 100, 3.14 as it is 60, 1s are 16, 360 degrees divided. So it will get the 6 only. So here we'll write the 3.14 upon 6 only. Sin 60 degree, that value is root 3 upon 2 upon 2. Correct? Then we have to multiply it properly. So what will we get? 100 in bracket 3.14 upon 6. That 2 is multiply in denominator. And what is the root 3 value? That is 1.73. That is the given, and 2 2s are 4. So here we'll get the area of shaded region, that is 100 in bracket 3.14 upon 6 minus 1.73 upon 4. Correct? So area of a shaded region, that is 100 in bracket, we have to try to same the denominator, that is 12.56 minus 10.38 upon 24, that is 100 in bracket 2.18. We have to subtract it properly, we'll get the 2.18 upon 24. So what will we get? 100 into 2.18, that is 218 upon 24, that is 109 upon 12. So what will we get? That's the 9.08 square centimeter. So what is the area of a shaded region? That is 9.08 square centimeter. So here we'll get the first 3 question. Then question 4 is the like of Hertz type question. So focus on question 4.1a. Here diagram is also given. Show that the radius of a in circle, that is OQ, OR is the radius of a in circle, correct? That is a given R. The show that the radius of a in circle of a right angle triangle is equal to the difference of half of the perimeter and the length of it diagonal of that triangle. So given, what is the given? Triangle ABC, right angle triangle, measure angle ACB is equal to 90 degree. R is the radius of its in circle. BC, that value is A. AC, that value will be B. AB, that value we consider C. So what to be proved? R, that is radius of a in circle, is equal to the difference of half of the perimeter and the length of its diagonal. Means length of its half perimeter. Perimeter means length of a 3 side, that is A plus B plus C, upon 2, that is the semi perimeter, and diagonal is nothing but AB, that value is C, so minus C. So when we start with the proof in triangle, in the circle with center O, AR is equal to AP. We have to consider here X. CR is equal to CQ. We have to consider here Z. And BP is equal to BQ, that is the Y. So focus here, tangent drawn from same external point of the theorem. That is here tangent drawn from external point, that will get AR is equal to AP, CR is equal to CQ, and BP is equal to BQ. Correct? So put the given value. A plus B plus C. According to the diagram, we have to put that value Y plus Z plus x plus y plus x plus z. That will get the 2x plus 2y plus 2z. That is 2 in common, x plus y plus z. That is here we'll get this 2 is multiply. When we change the side, it is divide. That is a plus b plus c upon 2 is nothing but x plus y plus z. Now focus on a quadrilateral ROQC or OQCR. That is segment OQ perpendicular side BC. That is the tangent theorem. Segment OR is perpendicular. That is the AC. That is again tangent. Okay. Here, these both the angles are 90 degree and angle C is also 90 degree. That indicate that a quadrilateral OQCR is a rectangle. Correct? What is here? Angle OQCR is a rectangle. That is OQ is equal to OR. That is the opposite sides are equal. So rectangle OQR is also square because OQ is equal to CQ. That is the side of a square, and R is equal to Y. That indicates that this is a square. So all sides are equal. So it is a radius. Now, when we focus on a diagram, C is nothing but x plus z. So first equation become a plus b plus c upon 2. Where is our first equation here? Sorry. Focus here. A plus B plus C upon 2 is equal to, see here, this is our first equation, A plus B plus C upon 2, x plus y plus z. So C is nothing but x plus z, correct? C is nothing but x plus z. So here we have to write C is equal to x plus z. So A plus B plus C upon 2 is equal to C plus R. So arrange it properly. So this R is remain as it is, that plus 3 shift other side. So it become our proof. That is R is equal to A plus B plus C upon 2 minus C. This is our first question completed. Then focus on a second question, that is a mensuration. That is, find the length of 13.2 kg copper wire of a diameter 4 mm when 1 cubic centimeter of copper weight 8.4 gram. Here, what is the given? Weight of a copper wire, that is 13.2 kg. It's converted into gram. So it multiply by 1000. So 13,200 gram. So volume of 8.4 gram copper wire is 1 cubic centimeter. That indicates that volume of 13,200 gram copper wire is nothing but 13,200 upon 8.4 cubic centimeter. Means here volume of a copper wire is given. Then diameter of a wire is 4 millimeter. That is, it converts into centimeter, that is 0.4 centimeter. So what is the radius? It divided by 2, that is 0.2 centimeter. So volume of a copper wire is just cylinder shape. That is, we have to write volume of a copper wire, that is pi r square h is equal to 13,200 upon 8.4. Correct? What will write here? That is pi r square is equal to 13,200 upon 8.4. Put the all given value. Pi replaced by 22 upon 7. R square is replaced by 0.2. And H, it is remain as it is. And here volume of a cylinder or a copper wire. So we have to find out the value of H. That H remaining as it is, and all value we have to shift the other side, correct? So what will we get? Here we'll get 13,200 into 7 upon 8.4 into 0.2 into 0.2 into 22. That become the answer 12,500. That is 125 meters. So what is the length of a copper wire? That is 125 meter. Here we'll get or completed question number 2. Then focus on a third question. It is a construction type. That is, two triangles are given. Triangle AMT. Similar triangle AHE. In triangle AMT, MA is equal to 6.3 centimeter. Angle MAT is equal to 120 degree. AT is equal to 4.9 centimeter. And MA upon NA, not NA, it is a HA is equal to 7 upon 5. Construct the triangle AHC. So first we have to focus here, vertex is a common. That means we have to try to similar triangle by common vertex. So A is a common vertex. So try to first draw a triangle AMT, correct? That measure is given. And when we focus on the ratio, that is AH is the smaller triangles. So our given triangle is bigger and AHE triangle is a smaller. So our construction is to bigger to smaller, correct? So our second diagram is in a triangle. So try to draw a first triangle AMT having proper measure. Then draw one acute angle, that is angle MAA7. We have to draw the 7 same parts and we have to continue whole construction like this way, correct? Here our question 4 is completed. Then focus on question number 5. This is very simple question. That is, if A cos theta plus B sin theta is equal to M and A sin theta minus B cos theta is equal to N. Prove that A square plus B square is equal to M square plus N square. So we have to equate equation 1 and 2. That is, we have to numbering them. A cos theta plus B sin theta is equal to m. That is equation 1. A sin theta minus B cos theta is equal to n. So first equation 1 we have to square it. That will get m square is equal to in bracket A cos theta plus B sin theta bracket square. That means we have to use the formula a plus b bracket square, that is a square plus 2ab plus b square, correct? So we have to write that way. So here we have to write, therefore that formula is like way a square cos square theta, that is 2ab sin theta cos theta plus b square sin theta. Then we have to also same way squaring the equation number 2, that is n square is equal to in bracket a minus sin theta minus b cos theta bracket square. That is, we have to again use the formula a minus b bracket square. That is, here we write a square sin square theta minus 2ab sin theta cos theta plus b square cos square theta. So adding equation 3 and 4. So what will we get? M square plus n square, m square plus n square is equal to a square cos square theta plus b square sin square theta plus 2ab sin theta cos theta. In second, a square sin theta b square cos square theta plus minus 2ab sin theta cos theta. That plus minus get cancelled. So here we have to arrange a square in first bracket and b square in second bracket. So what to be right here? A square in bracket sin square theta plus cos square theta, b square in bracket sin square theta plus cos square theta. So what will we get? That is m square plus n square is nothing but sin square theta plus cos square theta is our identities. That value will be 1. So a square plus b square. So we have to easily prove that m square plus n square is equal to a square plus b square, correct? Then here we have to focus on the last question. So what is that last question? Two circles which are not congruent touch externally. The sum of their areas is 135 centimeter square and the distance between their center is 14 centimeter. Find the radius of a circle. So here we have two circle having externally touching, having radius r1 and r2. So what is the given? The distance between two center is a given. That is r1 plus r2 is equal to 14 centimeter. We have to write the value of or find the value of r2, that is 14 minus r1. So we know that the area of a circle, what is the area of a circle? Pi r square. So area of a circle having center A, that is pi r1 square, and area of a circle with radii r2, that is having center 2, that is pi r2 square. That is, what is the value of r2? That is 14 minus r1. We have to put here. So according to condition, pi r1 square plus pi 14 minus r1 bracket square is equal to 130 pi. That is our condition, correct? So here we have to put that all value according to condition. That is pi is a common. So divide throughout by pi. So what will we get? R1 square plus 14 minus R1 bracket square is equal to 130. Correct? So we have to solve that bracket 14 minus R1 bracket square. So what is that bracket square? That is a square minus 2ab plus b square. So according to that condition, according to that condition, here we have to write 2r1 square minus 28r1 plus 196 minus 130 is equal to 0. We'll get one quadratic equation, that is 2r1 minus 28r1 plus 66. Divide by throughout 2. So what will we get the easy question? That is r1 square minus 14r1 plus 33 is equal to 0. So we'll get the multiplication will be 33 and factorization means addition will be 14. That means here we'll get the factor minus 11 and minus 3. So solve it by factorization method. We'll get the R1 value 11 and R2 value is 3. That means the radius of a circle. What is the radius of the circle? That two circle which is touches externally, that is equal to 11 centimeter and R2 is equal to 3 centimeter. So here we completed our third prelim maths 2 question paper. Thank you.